MFHF SSB radio communication is a fascinating topic that plays a crucial role in maritime safety. These radios operate within the medium and high frequency ranges, typically from 1.6 MHz to 30 MHz. Unlike VHF radios, which rely on line of sight communication, MFOHF radios utilize a remarkable phenomenon known as sky wave propagation. This allows their signals to bounce off the ionosphere, enabling communication over vast distances, often thousands of miles beyond the horizon. Despite the advancements in satellite technology, MFHF SSB radios remain indispensable. Why? Because they provide a reliable backup when satellite communication fails. There are numerous dead zones around the world, areas where satellite signals are weak or non existent, such as polar regions or remote ocean stretches. In these situations, MFHF radios ensure that ships can maintain contact with shore stations or other vessels, regardless of their location or the challenges they face. The term SSB stands for single sideband, a modulation technique that enhances the efficiency of communication. This technology allows ships to not only send voice messages, but also transmit telex messages, which are essential for routine reports or urgent updates. Most importantly, SSB radios are vital for sending distress alerts, a key component of the Global Maritime Distress and Safety System, or GMDSS. This system ensures that ships comply with international safety standards, making it easier to coordinate rescue efforts in emergencies. Merchant ships use specific frequencies for both routine and emergency communications. For distress calls, the primary frequencies are 2 to 182 kHz on MF and 4125 kHz on HF, which are constantly monitored by shore stations and other vessels. For ship-to-ship communication, frequencies like 6255 kHz and 8291 kHz are commonly used, while long-range communication often occurs on frequencies such as 12290 kHz and 16420 kHz. Understanding and properly utilizing these frequencies is essential for safe maritime operations. In emergencies, sending a distress alert via MFHFSSB is a critical procedure. Ships primarily use Digital Selective Calling, or DSC, which allows them to send a coded digital alert with just the push of a button. This alert automatically transmits vital information, including the ship's identity, position, and the nature of the distress. Following the DSC alert, a voice transmission provides further details, ensuring that rescue teams have a clear understanding of the situation. Maintaining MFHF-SSB radios is non-negotiable for maritime safety. Regular testing is essential, and ships conduct daily radio checks to ensure their equipment is operational. Antenna inspections are crucial for identifying any physical damage or corrosion that could affect signal quality. Power output tests confirm that the radio is transmitting at optimal strength, and DSC test calls are performed to ensure the digital alerting system functions correctly. These routine checks guarantee that the radio is ready to perform when needed most. Mistakes can happen at sea, such as accidentally sending a distress alert. In such cases, it's vital to immediately send a cancellation message on the same frequency, clearly stating the error and confirming that there is no actual emergency. Prompt cancellation prevents unnecessary search and rescue operations, conserving valuable resources. The world of MFIHF SSB radio communication is a testament to the resilience and reliability of maritime communication. These radios are far from obsolete. They remain a vital backbone of safety at sea, ensuring that ships can stay connected even when satellite systems fail. Their role as the unsung heroes of the high seas cannot be overstated.